I've always loved game development. It's a way to express the artistic side of myself through a technical outlet. Graphics especially, seeing all these artistic effects could be created from just math. A project I built to explore graphics was a 3D rendering engine in Desmos. Before long I started trying to render 40 cross-sections. I didn't have much direction for this part, there's no 4D rendering tutorials online, but that process of just trying to figure everything out was my favorite part. I looked for another project that could do the same.
Which brings me to spherical geometry. I've been simulating if the fabric of 3D space was curved into a 4D sphere. In spherical space, straight lines converge. You'll immediately notice some weird visual effects. Space kind of rolls out before us, it looks like the ground curves upwards, objects look bigger as they get further away, and this is all because the curvature of space bends light. Curvature also affects the paths objects move in. Kicking a ball one way has it loop back around the world over and over again. I made a small game with these tools. It's basically first-person Snake but in spherical space. It's a fun way to get an intuitive feel of non-Euclidean geometry. To build this, I first had to find a way to represent transformations of spherical space. I quickly got the idea to represent position and orientation as a single 4D rotation, though the actual method for generating and storing those rotations evolved drastically throughout the project. Same for physics and lighting. None of the typical methods for detecting overlapping colliders or calculating shadows could be applied in curved space. Like 4D Desmos, I had no idea where to even begin or what math to even use. So I experimented. I explored areas of math I would have never otherwise seen. Most of it didn't even end up in the final project. Some things were important stepping stones in reaching solutions, others had no benefit or were just cool to learn about regardless. Space-time I found so interesting it branched off into its own project, a simulation for if the speed of light was really slow. At near light speed, space looks stretched ahead of us and compressed behind us. By coloring each pixel by its local time, you can visually see time dilation. This really helped me understand the twin paradox. It's also just kinda cool, seeing the Doppler effect with light or that shadows can all point towards each other. That's my favorite part about making projects like these. I only got interested in math because I saw these beautiful depictions of it, which I didn't understand at the time, but I desperately wanted to. And so I love taking abstract areas of math and visualizing them in a way that non-math people can still appreciate.